So today we're going to start chapter 4, which is all about an introduction to functions, and specifically this section is about using graphs to relate to quantities. So first thing I want you guys to do is you're going to copy down the blue, you're going to fill in the blanks. It says that we can use graphs to visually represent the relationship between two variable quantities as they both change. So all that means is that you're comparing two different variables in a situation where they're both changing and you're seeing how they're related to each other. So in this first example, it says that the graph below shows the volume of the air in a balloon as you blow it up until it pops. What are the variables? And describe how the variables are related at various points. So as we can see right here, our variables are going to be our time and our volume. So those are the two things that are changing. So our variables are time and volume. So as we can tell, we want to start at 0. So as time increases, the volume is changing. So we're going to figure out what it's actually happening. So in our problem, it tells us that the volume is increasing as you blow up the balloon. So as you can see, this steep right here, this is where our volume is increasing. So we're increasing, and then you see how it tips off right here and it stops for a little bit. I think that this is where somebody maybe is taking a breath. Taking a breath. Okay, so they stop blowing it up, but the balloon is not losing any volume of air. And then again, it increases in volume, stops for a little bit, increases in volume, stops for a little bit, increases in volume, and then we can see it pops, and instantly all of the air comes out. So as you can tell, right here is the point where the balloon pops. So all I really want you to do is take a few points on the graph and figure out what's happening at that very time. So right here we can say air is going into the balloon. Right here we can say somebody's taking a breath. Right here we can say air is going into the balloon. And here we can say again that the balloon has popped and all the air is coming out of the balloon. So it's all about interpreting the situation, figuring out what our graph is actually telling us, and then going from there. So next on your paper, you have these two graphs. What I want you to do is, again, describe what the variables are and then how the variables are related to each other at various points on the graph. So this one on the left is going to be about June's cell phone cost based on the minutes that she's calling. And this last one is board length. As time increases, the board length looks like it decreases. So you guys can make it what it is. You can create your own story that goes along with it. There's no right or wrong answer. You just have to be interpreting the graph in the proper way. So next up, our example 2, we're given a table, and on this page we are given a choice of 4 graphs. I believe that on your paper you have to draw your own graph that matches up, but that's okay. So the situation says that a band allowed fans to download its new video from its website. The table shows the number of downloads after 1, 2, 3, and 4 days, as we can see right here. And then we can see the amount of downloads that are related to that day. So it looks like on the first day there were 346 downloads. On the second day there were 1,011 downloads, and so on. So it wants us to figure out which one of the graphs, A, B, C, or D, could represent the data in the table. So just at first glance, we can see that the total downloads are increasing, right? So these are increasing as the days increase. So I know automatically that D is not an answer, because I can see that as the days are increasing, the total downloads are decreasing, and that's false. So now I want to take a look at A, B, and C and figure out what the differences are so I can then figure out which one is correct. So in graph A, it really looks like there is a constant amount of downloads being added per day. So it's like doubling or tripling or whatever the case may be, but it's constant. And I don't think that that's the case here. It looks like it's really growing, right? So we started with 346, and on the fourth day we ended up with over 10,000 downloads. So this doesn't seem to be correct either. It looks like we're growing really fast. So we need to look at the difference between B and C. Now, C over here, it looks like we start increasing, but then it starts to plateau almost and stop increasing and just stay kind of stagnant. But again, that's not happening. On the last day, we go from 3,000 to 10,000. That's a huge jump. That's more than what we jumped from day 1 to day 2. So I'm looking at B. So on your paper, you guys need to graph just something that looks like this. So this is like an exponentially growing equation. Well, not necessarily an equation yet, but it's growing really quickly, the amount of total downloads that you have. So B is going to be your best bet. So just do a rough sketch of how B looks. It's growing, it's starting off a little bit slow and then it goes really fast. So if you were to graph day 5, it would probably be somewhere all the way up here. It's just going really fast. The next one is for you guys to try on your own. So it gives you the graph and it gives you the table and it wants you to graph it. So it's talking about the amount of sunscreen that's left in the bottle after the number of uses that you've used it. So zero times the sunscreen's been used and there's 5 ounces. It's been used once and there's 4.8 ounces. Used twice and there's 4.6 ounces, and so on. And it wants you to graph this based upon the data. So if you were to, I'm not going to graph it for you, but I'm just going to set it up. If you were to set up your X and Y axis, we would have number of uses down here. And then this would be amount of sunscreen on the left, with your 0 down here. Okay? All right, so last up. This problem is asking us to graph the situation. So it says that a model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What is a sketch of the graph? What sketch of the graph could represent the height of the rocket during its flight? So we need to label our graph, we need to give it a title, and we need to label each section. So the title I want to give this is going to be the model rocket flight. Model rocket flight. So we're talking about height, and we're talking about height over time. So our time is going to be down here, and our height is going to be over here. Now, we're not using any numbers yet. We just want to show maybe what the height is going to be over time. So if we read this problem, it says that a rocket rises quickly and then slows to a stop. So the way that we're going to represent this is we are going to rise quickly. So this is the part that's rising quickly. And you guys want to label your graph as well. We are rising quickly. Then it says it slows to a stop. So it's going to stop. It's not falling yet, it's just stopping. So this is where it stops. Okay? And then it says as the fuel burns out. So it's going to fall quickly now as the fuel burns out. Falls quickly until the parachute opens, and then it falls slowly back to Earth. So right here is where your parachute is going to open. So parachute open. Okay? And then it says it falls back to Earth, but way slower. So we were at a drastic decline here. You were about to be on the ground. But now we're going to slowly fall back to Earth. And it's going to take a lot of time, so from here to here, to fall back to Earth. So this is slowly falling to Earth. And right here is going to be the point where you are on Earth. because your height is 0. Okay, so this is all about interpreting the problem and in the context of the problem and drawing the situation. Okay, thanks a lot, guys. Have a great night.